Hello and welcome you guys to my new tutorial about the things you should know. Actually, in this lecture I will talk about the phenomena why colors look like they look. Okay? It's a pretty simple question that you might ask yourself. Why does red look like red, or black looking like black and white, and other colors look like they do? To understand that, we first have to understand the nature of light itself. And there is a very famous experiment with light. If you take light of a sun or just white light and you let this hit a prism, okay, just a glass shape like this, and what will happen is actually you will get your light scattered here. It will open up its branches, and then if you have some screen here, you will actually see this kind of pattern. In the upper corner you have red, and you see it's going to black. And actually, so it will not be visible anymore, but actually this is red, and it's this is the wavelength. We will talk about that later. And here we have 400 nanometers, which is pretty short. What is the wavelength? The wavelength, you can imagine yourself light, different kinds of light have different wavelengths, and this wavelength gives them special features. Okay, wavelength is if you imagine a water bath and you hit your hand on the water surface, and you will see waves coming up, and they seem to have some wavelength, and this is actually what it is. The wavelength, it's pretty short. It's just a physical measure. Okay, and you see what happens with the white light. If it hits the prism, it will just so to say open itself with all the colors that are hidden in the white. So this kind of thing is called the electromagnetic spectrum. Okay, electromagnetic spectrum, and this is the visible part of it. Okay, and now what happens next? To understand that, you have to have a slight idea about the human eye. The human eye, and what actually happens here is the human eye has a retina, and on this retina there are different kinds of cells. Okay, and the important cells for the sensation of colored viewing are three cones. Okay, there's first of all the cone that is called the S cone. It's violet meaning that it's very sensitive to the violet part of the electromagnetic spectrum, and actually S stands for short wave. Okay, if you go back to this picture, you see this is tending to violet, and its wavelength is shorter than the red part. Okay, so we have this S cone, we have another cone, it's the M cone for middle, which is actually represented by green colors, and then you have the L cone, which is red. And if you just try to experiment with all these colors while the S cone is also kind of blue, then what you can see is that you can actually mix them and get any color that you want. It's just if you look here, these corners are, so to say, the pure colors. This is blue, this is red, and this is green. And if you mix them all together in the same amount, you will end up to be here somewhere in white, and you can get other colors. Okay, this is so to say, when mixing these three colors, and this is what happens in your brain. Your brain takes there's some light coming on this, and the light will have special wavelengths, and they will actually selectively so to say activate these cones. For example, if you have dominant red wavelengths, so long, this is long, then only this will be activated, and you will have red sensation of looking at something. And this, if this the M cone is activated, then you will have green sensation and so forth, and then you can actually mix them and get any color that you want. Okay, and this is actually this is not the precise explanation of that, but this is something like this, so you understand that. Okay, now you know how the human eye works. Here some little more. They have a specific part of the electromagnetic spectrum where they are working very good. So the S cone at 450 nanometers, the M cone at 540 nanometers, and L cone at 580 nanometers. This is at these wavelengths they are very, very sensitive, and they will fire, so react very, very strong. Now let's look what happens then. Okay, the next topic, so to understand, is absorption, which is actually very, very similar to reflection. I have here such a I'll show you this ugly t-shirt, this ugly black t-shirt, and what will happen here is the light is hitting the t-shirt. What will happen with the light is it will absorb this black color, gives your material a very specific feature that it absorbs almost everything from the electromagnetic spectrum, from the visible. So this is what we can see. And what happens if you if all three cones are not activated? Because sorry, I just jumped ahead. So if you have this black t-shirt, it will absorb all the electromagnetic spectrum parts. What will end up is that nothing, almost nothing, is reflected, and nothing will hit your eyes or your cones. And if no cone is activated, you have a dark sensation. It's actually the same as if you would close your eyes, then you would see black. Now the other example is the red t-shirt. Okay, here we have again light hitting this. What will happen is that the light color gives your t-shirt the property that it will absorb almost everything from the electromagnetic spectrum, but only a red part will be left. So what will come here is red. So the light that is reflected from your red t-shirt is only in the red domain, meaning only the L cone will be activated, and if this hits your brain, you will have a red sensation. Now the last case, so is the white t-shirt. You have a white t-shirt, and the white t-shirt is hit by light. What will happen is that white color gives your object the property that almost nothing from the electromagnetic spectrum is absorbed. What does this mean? That everything is almost reflected. But if that light is reflected into your eyes, what will happen is that all cones are activated the same way, what means that you will get a white sensation. Okay, and actually that's it. There is nothing more than this to it. I hope you like this. Just remember the steps. It's very important that the light is not only white, it has its electromagnetic spectrum from blue to red, so to say. And if this hits an object, this object will absorb a part of the electromagnetic spectrum, and what is reflected will hit the observer's eye. And the eye has three kinds of cones, and following the rules how they are mixed, you will get some kind of sensation in your brain, so it will appear red for you. Okay, so I hope you like that video. If you still have questions, feel free and comment. Okay, see you guys.